scientists! It's so great to see you again for another episode of SCFG Live! Science Club for Girls Live. I'm Hannah from Science Club for Girls, and that was Mr. Music with your theme song. Wow! Switching it up. I like it. Very nice, Mr. Music. Well, it's so great to see everyone. It's been, I think, 2 weeks since we've seen each other, and it's been even longer since we've seen Dr. Marbles. So let's bring him in and see what he's been up to. Hey!
Hi, Hannah!
How's it going?
Oh, it's great. How are you?
I'm good. I see that you're wearing a mask. Is that because you were on vacation recently?
Yep. I was
Tell
on
us more
vacation.
about it.
Well, what can I say? It was a different kind of vacation this year, that's for sure. But you know what? Most importantly, I got a chance to rest a little bit and kind of re-energize, and it was nice. But of course, I was social distancing.
Of course. That's really important. And I'm sure you were washing your hands a lot, too.
Can you see the mask?
I do. It's lovely. Don't touch it. Don't touch it. But good job.
Very good point. Although I did wash my hands.
Good. I'm glad. Well, it's great to have you back. We missed you a lot last week, but I can't wait to fill you in on what you missed.
I can't wait.
Cool. Well, last week we actually talked all about weather. We learned how there's so many different components of weather, including temperature, air pressure, humidity, precipitation, wind, and all that kind of stuff. And we actually even got to make our very own thermometers to measure the temperature of the room and the temperature of a cup of ice water, which was really cool to see. So, do you feel like you missed out, Dr. Marbles?
Big time.
I know. Now, we've actually been experiencing some pretty crazy weather the last week or so. And that's because there was actually a hurricane that passed through Louisiana recently after traveling through the Caribbean. And that was Hurricane Laura. Have you heard of that, Dr. Marbles?
I have.
Yeah.
You know, there's been a lot of hurricanes, of course, over the years, but every time I'm really amazed by how much energy those hurricanes can carry.
Yeah.
I mean, how fast those winds are. Faster than a car.
Yeah, it's crazy. And good thing you brought that up, actually. Hurricanes can produce really, really strong winds and really strong rain. So I thought we'd kind of take a look at some footage from a real hurricane. You want to see?
Yeah, definitely.
Cool. Let's take a look. Don't get blown away, Dr. Marbles! He's getting blown right off the screen! Oh, no. Pretty scary. Dr. Marbles, come back!
Wow.
Yeah.
Those wind forces were incredible.
They were. They're really strong, and they can often cause a lot of destruction. And we'll talk about that in a second. But hey, Dr. Marbles.
Could you see how the wind was blowing me?
I saw you literally got blown right off. Yeah, amazing.
Yeah, it was incredible.
Just like that. Very cool. But hurricanes usually and tropical storms tend to form in areas that have warm water because hurricanes need warm water and warm air in order to form, which is why we often don't get hurricanes here in Boston because it's just too cold.
Yep.
Yeah. Anyway, it's also really important.
Which is a good thing, by the way.
Right, it is a good thing. Sometimes we'll experience some rain as kind of like an aftermath of the hurricane, but we don't really get those super strong winds that they experience down in like Florida and Louisiana.
Yeah, we don't get anything like that. No,
exactly.
Thanks. No thanks.
Right. Now, it's also really important that those areas that experience hurricanes have really strong buildings, roads, and bridges that can withstand those strong winds and don't crumble. And that's the job of someone called an engineer, to make sure that those structures are nice and strong. Have you heard of the term engineering before, Dr. Marbles?
I have. Amazing people.
Yeah, very, very cool. So today, we're actually going to become engineers.
Hey, Hannah.
Yeah, what's up?
Isn't your brother an engineer?
He is an engineer.
Yeah.
Oh, I should call him and say hi.
His type of engineering's up on your slide.
That's right. He's a mechanical engineer.
Yeah.
Pretty cool. Now, Dr. Marbles, I heard you have a problem that we might be able to address today.
and it's not a small one.
Oh, tell us more about it.
Hey, I heard a rumor that you guys met my new puppy.
We did.
Wow,
Prediction puppy. He did a pretty good job last time making a prediction about our thermometer.
I've trained him well.
I'm sure you have.
Well, here's what's going on, Hannah. So Louis, when he goes to sleep at night, he's in a crate. And every night when I put him in the crate, he cries.
Oh.
Oh, no, don't worry. That's what puppies do.
Sure.
Although I wish he'd stop. So I heard that if you put a puppy at your height, at the height of your bed, then they don't cry. So what I'd love to do, and I could use an engineer to help me, is I would love to create a crate that could be at the height of my bed. You know, elevated. So I looked around at stores and I looked on different websites, and you know what?
What?
It doesn't exist.
So you mean we need to design something brand new?
Brand new. And that's the fun of engineering. You make things brand new.
You're right. Now, Dr. Marbles, I think we can actually solve this problem using something called the engineering design process, which is a series of steps that engineers go through in order to make a solution to a problem.
Let's get started.
Let's start it out. Well, the first step is an easy one. What is the problem you need to solve? Dr. Marbles, tell us again, what's the problem?
I need a crate for Louis that can be raised to the height of my bed, so he doesn't cry and keep me awake and make me crazy.
Right. Great. Now we have the problem. Next, we need to do some research, meaning we need to see what's already out there. What kind of materials are already being used to make dog crates?
Well, most crates, as I could find, were made of steel or they're made of plastic. But none of them can be put to a higher height, so I don't know. I've been using a chair, but the problem with that, of course, is it's not totally safe. So I really don't like using it.
That's a good point. So we know what's already worked before. We also know what doesn't work. So maybe we can start to brainstorm some ideas. So let's think of all the different type of materials we could use to build this crate.
Okay. First ones that come to mind, wood, steel,
Okay.
plastic,
Okay.
and you know what, Hannah?
What else?
I have a feeling that there's other materials I'm not thinking of. And I need a materials scientist. Who thinks about this? A materials engineer who really understands the kind of materials that are out there and can give me options.
That's a great point. Oftentimes during the brainstorm and research stage of the engineering design process, engineers will actually talk to experts and sometimes other engineers to work in teams and brainstorm ideas together.
That's the most fun part of engineering, I think, is the collaboration that people do.
Definitely. Well, good point. Now it's time to plan. So Dr. Marbles, this is where you want to sketch or draw out your ideas.
Yep.
Choose one that you think will work well and draw it out.
Well, I must say, check. I started doing it already.
Let's take a look.
Yep.
Very cool.
Right?
Dr. Marbles, it looks like you have legs on there. Do those legs go up and down?
They do, Hannah. I can walk you through the diagram if you'd like.
That'd be great.
Well, as you can see in the center, my man Lou.
Oh, there
And
he
there's
is.
his crate. And then I call it leg 1, which is the leg on our left, but Louie's right. And then I have leg 2, which is on Louie's left, our right. And then I've got this, well, the beginnings of what I like to call my pulley system. So I can lie in bed, and I have two options. If I'm lying in bed, I can pull the pulley. You see that rope that's coming down?
Yep.
And if I pull the pulley, the crate goes up. But I also wanted an option that once I'm standing, I can lower it. That's where the crank comes in. Roll the crank, Louie goes down.
Very cool.
And that's kind of what I've got so far. Some engineers call that back of the napkin.
Because it's often drawn on the back of a napkin.
Yeah, most great ideas end up on the back of a napkin.
Very true. Well, now that you have a design, you're ready to build what's called a prototype. This is a small model of what your big project is actually going to look like. Now, this step takes a bit of time because not only do you need to build something, but you also need to test it because oftentimes it doesn't work on the first try. And that's okay, right? You go back to the drawing board, you think, how could I make this better? And you redo it. That's what an engineer does. You redesign, improve, and then eventually you'll share your ideas with everyone. Now, Dr. Marbles, it might take you a bit of time to build and test, so why don't we check in with you in a little bit?
Sounds good. See you there.
We'll see you later. Well, it's exciting to use the engineering design process, and I think we're going to be able to do it with our own project today. Now, kind of cool. During the time we were checking in with Dr. Marbles, we were actually traveling at warp speed all the way to San Francisco, California to visit this beautiful thing called the Golden Gate Bridge. Now, here's the problem. The Golden Gate Bridge spans a mile all the way across the body of water. But there were really strong winds recently, and the Golden Gate Bridge collapsed. So it's our job as engineers to try to build a better and stronger bridge. You ready to take the challenge? Let's get started. The first thing we need to do is figure out what is the problem. What's the problem that we need to solve here? Well, the problem is we need to build a bridge. Specifically, we need to build a bridge that will span 1 foot across 2 stacks of books. We also need this bridge to be able to hold the weight of this truck. So, what's the next step? Now we have the problem. It's time to do some research. What kinds of bridges have been built before? What do those bridges look like? Let's take a look. Here's one of my favorite bridges. It's called the Zakim Bridge, and it's actually right here in Boston. What I noticed is that this bridge has what looks like kind of suspenders that are helping to hold that bridge up. It also seems like there's a lot of triangles in this bridge, so I'm thinking that might be a strong shape. Let's take a look at another bridge. Here's a Brooklyn Bridge in New York City. I see here that there's these strong kind of structures in the middle of the bridge that are helping to provide support. So maybe I'll do that with my bridge too. And the last bridge we'll take a look at is an arch bridge. This bridge is actually in Quebec, in Canada. Maybe something about the arch shape helps the bridge to be really strong. I'm going to think about these when I design my bridge. Okay, now it's time to brainstorm. Let's generate some ideas. So I'm thinking that, I'm going to use some, let's see, well, what do I have here? I have some index cards and I have some cardboard and I also have tinfoil. So I'm thinking I might use maybe the cardboard and maybe I'll make a long shape with maybe some triangles in there to make it nice and strong. That sounds like a good plan. Okay, now it's time to actually plan. So let's go ahead and draw it out. I'm going to change my camera so you can see my drawing as it's happening. All right, so let's go ahead and get started. Now, okay, so here are my books that I'm going to span across. And I know that it's 1 foot across. Okay, well, I have my cardboard, so maybe I'll do a couple of sheets of cardboard like that. And maybe I'll hold them together actually with binder clips. So maybe those binder clips will hold those pieces of cardboard together because they're nice and strong. Well, I think that should work because cardboard's strong and I think the binder clips will also help to add some strength. So let's give it a try. Okay, now the next step is my favorite step, and that's actually to build it. So let's go ahead and get started building our bridge. Okay, so the first thing, I think I'm going to take some cardboard and I think I'm going to hold it together with binder clips. You can definitely make a bridge at home and I'd highly recommend it because it's so easy. You can use so many different materials that you find around your house. Okay, let's measure this because I think it's not a foot yet. Nope, it's only about 10 inches. So we need another piece of cardboard. And put our binder clips. And another binder clip. Great. I'll measure it. Oh yeah, that's more than a foot. That's going to work. Okay, now it's time to test. Let's see if this works. Before we do that, let's make a hypothesis. Do we think this bridge will hold the weight of a truck? Write what you think in the comment section. All right. Here is our 2 sets of books and making sure that they're a foot apart. Yeah, okay. Here goes the bridge. All right. Let's count down. Ready? 5, 4, 3, 2, 1. Oh, I want to make sure that stands up. Oh no! My bridge wasn't strong enough. Well, remember when I was talking to Dr. Marbles and I was saying that oftentimes the first try it doesn't work. And that's okay. Now it's time to redesign. Okay, so this one piece of cardboard wasn't strong enough. What could I do to make my bridge stronger? Write what you think in the comment section. Great job, Franny, writing that she thought this may not work. You're right. Well, I know triangles are strong shapes because I saw in my research that a lot of bridges use triangles. So maybe I'll create a triangle that goes underneath my bridge from some other pieces of cardboard. Let's try that. Tape that together. And I might need, honestly, I don't think it's going to be tall enough, so I think I'm going to have to add another piece of cardboard on top. And I'll binder clip that together. If you do this at home, be sure to comment in the comment section, what materials did you use to build your bridge? Oh, Myra. Myra, thank you for clarifying. All right. So now we have our triangle. Okay. Now let's see what happens. Hypothesis. Do we think this will work? I think it should. Triangles are a strong shape. It works! Now, I do notice that it's bending in a little bit, so I could even go back to the drawing board a second time and do another redesign. Engineers are constantly redesigning and trying to make their products even better. That's an important thing about an engineer. Well, now that we have our bridge, we just got to send it to, the people in California and be like, here you go. But I'll do that later. Well, as I said before, there are so many different types of engineers out there, and they're all extremely important in solving so many of the problems that we experience on Earth. I actually have the lucky chance of being able to sit down with 2 engineers. One of them is a biomedical engineer, and the other one is a mechanical engineer. And they got to tell me a little bit more about what they do. Let's go ahead and take a look. Well, Carla, thank you so much for joining us on today's episode. It's fantastic to have you. Well, go ahead and just introduce yourself, your name, where you go to school, what you're studying, and how you're related to Science Club for Girls.
Okay, awesome. So my name is Carla. I'm currently a junior at Bunker Hill Community College, and I am double majoring in biomedical engineering and physics. And my relation to Science Club for Girls is that I volunteered at the King Open School last semester in the spring. So yeah, that's who I am.
So my name is Melanie Tribble. I'm a mechanical engineer. I work at National Grid on the gas side. So gas that provides anything to your house like heat, to cook, a bunch of the other different things. And I've been volunteering at Science Club for Girls for now. This is going to be my 4th semester.
Do you mind telling us a little bit more about what you do as a mechanical engineer and what is mechanical engineering?
Yes, so I've had a bunch of different jobs. So the cool thing about mechanical engineering is that it can be used in any area. So if you like planes, you can work on planes. If you like cars, you can do cars. If you like really anything. So my last job right now, like I said, is on gas. So there's like pipes underneath the road in front of your house that bring the gas to you, and that's what I work on to make sure they're correctly put, and then they're in the right location, if we have to move them or not. So that's what I do right now. So more design side.
It's great to hear that you're a biomedical engineer, because today we focused all about engineering. And we also talked about how there's just so many different types of engineering out there. Mm-hmm. And so I'm curious if you could tell us a little bit more about what a biomedical engineer does.
Yeah, absolutely. So basically we focus on the concepts and the ideas of engineering, so actually building things, but to be used in the medical field. So some examples are like artificial organs, or, you know, like robots that can actually be used within the body. So yeah, that's just a little bit of what we kind of focus on is engineering, but to be worked with into the medical field, which is perfect because I actually end up eventually in my career want to become a doctor. So this is perfect because I can get kind of the best of both worlds. So yeah, honestly, I love what I do and I love what I study. So yeah, I can't even say enough about it.
That's really cool. I love the idea of combining medicine with engineering.
Yeah.
And I think it's especially right now a really emerging field because there's so much that we can do to help in medicine and create new things. So that's fantastic. Can you tell us a little bit more about how you got interested in engineering and in biomedical engineering in the first place?
Yeah, sure. So when I was in high school, I actually didn't know what I wanted to study at all. And then when I was a junior, senior in high school, I started to become more and more interested into the medical field. And I always wanted to help people. I have a very, caring nature. I do what I can for other people. So I thought that, being a biomedical engineer, I could potentially save somebody's life one day. I could potentially build something and be part of a team that builds something to potentially save somebody's life. And that's what I'm passionate about. And I love studying it. I love what I do. And I wouldn't change it for anything. So,
So in today's episode, we also talked about the engineering design process and how engineers really have to brainstorm and plan before actually building something. And oftentimes they have to redesign something if it doesn't work the first time. And I'm curious how you use the engineering design process in your work.
Yeah, so for example, before this job, I used to work on the electric side. So let's just say, for example, I'm building a house and a piece of land and there's no houses around me. So how would we give you light? How would we give you heat? So we always start with the problem, which would be how to bring the electricity to your house, and then design it, brainstorm a bunch of different routes to make sure we're not running into something else and then something explodes or something. And then the solution would be the final route and send it to construction for people to come and put the pipes or poles near your house.
Awesome. Yeah, really important to plan first because like you said, you don't want it to explode or go everywhere. So very important. Great. And my last question is if you have any advice for all of the young viewers out there, it can be about really anything.
Yeah, I think especially as a woman engineer, I think it doesn't matter if you are a woman, you can be any kind of engineer. I think also growing up, I learned never be scared of being smart because I was always very smart, and I know sometimes that's looked down upon, but I always felt proud of that, being smarter than any other person in my class, and that's okay if you like math, science. That's really, really cool. So I think just embracing your smartness, being a woman, and being able to be in any field you want.
If we have any young viewers out there that are interested in going into engineering or specifically biomedical engineering, what advice would you give them?
Yeah, absolutely. So for one, of course, be part of Science Club for Girls because it's just one of the best things. And I wish I knew about it when I was younger, but I unfortunately didn't. But now I have the opportunity of being part of such an amazing group of volunteers and a bunch of staff that just encourage young girls to be part of STEM. So one advice that I have is just to never doubt yourself, honestly, and never be afraid to say that I don't know. because there's always going to be somebody that knows more than you. And always be willing to learn, always be willing to soak up as much information as you can, because you can do it.
Hey, Dr. Marbles.
What did I think?
What'd you think?
Oh, I was just like super impressed, maybe. I mean, unbelievable work these girls are doing.
Yeah.
Well, first of all, how many times do you think about the electricity that's going to your house?
I mean, rarely. I turn on the switch and the light turns on.
Exactly.
Right.
Meanwhile, people like Melanie are making sure that that's happening every single day.
Yep.
So that our TVs work, our lights work, our heaters work, our computers work. I mean, it's unbelievable. We just don't think about it, and sometimes we take it for granted. But
Definitely.
we must be so thankful for engineers like Melanie.
You're right.
And then what Carla's doing, I agree, is super cool, that she's combining her interest in engineering with medicine. And I'll tell you, Hannah, with the way things going in medicine, there's so much technology.
Right.
And having smart engineers that are able to create the right technology to help patients, wow, unbelievable.
Yeah.
So those two women just completely impressed me.
Yeah, me too. And I thought it was just so interesting how they both shared this, common interest in engineering and in making things, but for very different reasons, which was really cool to see. Well,
a couple of thoughts, though, I was going to share in the end.
Yeah.
Here's some words that came to mind when I was listening to Melanie and to Carla.
Okay.
They need to be able to plan and be organized.
Definitely.
And I'll tell you, there is no people more organized than engineers. They're trained to do it.
Exactly.
They need to be organized. So that's incredible. But they also have to be able to dream.
True.
They have to be open-minded. They have to let big ideas come to them and make bridges.
Right.
And really, they have to be the dreamers. And the last thing is they are just inherent collaborators. They're team players, engineers. And they form the greatest relationships so they can build great things for you and I. So
right.
Thanks for letting me be a part of this one, Hannah. It was really great to meet those women and to work with you guys, scientists.
Of course. Well, I wish you good luck, too, with the Louis Crate project. You'll have to fill us in on how that's going.
Yeah. I think I'm going to need some help.
I think you might. Maybe Louis can help you out.
Yeah. I started measuring some wood and stopped.
Okay. Well, at least you got to that step. Anyway, it was so great to have you, Dr. Marbles, on our show, and it was so great to have all of the scientists at home. And I hope you can join us again next week for another episode of SCFG Live. Thank you so much. If you want to learn more, check out scienceclubforgirls.org.
Take care, scientists. Bye.